Alright, the next equation we're going to solve is the natural log of x minus 3 equals the natural log of 2x minus... This one's actually an easier one because it's already set up. Right, if I've got the same bases on both sides, it's just what's inside have to be equal. And so my x minus 3 equals my 2x plus 1, and then I just solve for x, so it's however you want to solve for x. I'll move my x over, and so I get negative 3 equals x plus 1, move my 1 over, and so x equals negative 4. Alright, so this is one of those cases where if I go to check this, I get an error on both sides, and so we throw that one out. This one has no solution, right? If I throw out all of my possibilities, meaning there is no number that I can plug into the natural log of x minus 3 to make it equal to the natural log of 2x plus 1. So, no solution in that case. Alright, next example. Alright, so base 2, so I'm going to raise it to the 2, so 2 log 2 of x squared equals 2 raised to the 4. So x squared equals 2 to the 4th, and it's up to you, you can simplify 2 to the 4th. I'm going to leave it because I know I'm going to take the square root, so plus or minus the square root of 2 to the 4th. Which is going to leave me with 4 and negative 4. Alright, then I check to see if 4 and... So I get two answers, x equals 4, x equals negative 4. And if you take the square root of 2 to the 4th, which is the square root of 16, I get two answers, 4 and negative 4. In this case, they both check, right? Because that square term, if I plug 4 in, it's fine. If I plug negative 4 in, it's fine. And so both of them check. I keep both of them in this case. Alright, so both answers work. I don't need to throw any of them out. No extraneous solutions. Alright, the next example. Okay, so I've got the natural log of x squared minus 4 minus the natural log of x plus 2 equals the natural log of 3x minus 1. Alright, first step. I've got two natural logs on the left side, so I've got to reduce those down to 1. And so I combine minus by doing division, so it's the natural log of x squared minus 4 over x plus 2 equals the natural log of 3 minus x. Alright, now there's a couple ways you can go ahead and simplify this. So first of all, because it's the same base, I can set them equal to each other. So x squared minus 4 over x plus 2 equals 3 minus x. Then this side actually reduces. X squared minus 4 can be rewritten as x plus 2, x minus 2 divided by x plus 2. That's like reducing a fraction. If I had 8/4 there, right? I could reduce 8/4 into 2. Same thing here. I can reduce that into x minus 2 equals 3 minus x, and then it's pretty simple to solve. I'm going to add the x to the other side, and so I get 2x minus 2 equals 3, add 2 over to the other side, I get 2x equals 5, and so x equals 5 halves. Then I have to check to make sure my 5 halves doesn't give me any imaginary numbers, or not imaginary numbers, any negatives. And so I got to check this one's fine, 5 halves squared minus 4 is fine, 3 minus 5 halves is fine, so it checks. Right, so you got to plug them back into here and make sure you don't get a negative number or a 0, and it doesn't, so this one is the correct answer. It checks. Alright, so we'll stop there. The next example we're going to look at is cases where you have to solve. All of these you could have solved graphically. You could have. So if you're really running into trouble and you couldn't figure out how to solve it by hand, you could always solve them graphically. And the next examples I'm going to go over will actually be cases where you have to solve them graphically.